What are the internal mechanics of a JavaScript promise? Imagine you are waiting for a package to arrive. You don't know exactly when it will come, but you trust it will. That's similar to how promises work in JavaScript. They are objects that representing a task that will finish in the future. But how do they do this under the hood? Let's explore the internal mechanics that make promises so powerful and reliable for handling asynchronous tasks. When a promise is created, it starts in a state called pending. This means the task it represents has not finished yet. The promise then waits for the task to either succeed or fail. If it succeeds, the promise moves to a fulfilled state. If it fails, it transitions to a rejected state. These changes happen when the functions called resolve or reject are executed inside the promise constructor. Think of resolve as saying, "Yes, I got it," and reject as saying, "No, something went wrong." Promises also store callbacks that are functions to run once the task completes. When you use the then method, you are attaching a callback to handle the success case. If you use catch, you attach a callback for failure. Internally, promises keep track of these callbacks in lists called reactions. When the promise changes state, it goes through these lists and executes each callback in order. Inside a promise object are some hidden properties that keep everything organized. One is called PromiseState, which tracks if the promise is pending, fulfilled, or rejected. Another is PromiseResult, which holds the value if the promise is successful or the reason if it fails. There are also lists called PromiseFulfill reactions and PromiseReject reactions that hold the callbacks waiting to run. Additionally, a property called PromiseSHandled indicates whether any callback has been attached, helping manage unhandled rejections. Understanding these internal parts helps you see how promises manage asynchronous code smoothly. When you chain promises with then, each call creates a new promise that waits for the previous one to finish. This chaining allows you to run multiple asynchronous tasks in order. If an error occurs at any point, the catch method catches it, preventing your code from breaking. Methods like Promise.all, PromiseRace, and Promise.any help you run multiple promises at once, managing concurrency effectively. By knowing what happens inside a promise, you can write clearer, more predictable code. You'll understand how asynchronous tasks are tracked, how callbacks are stored and executed, and how to handle errors gracefully. This knowledge makes working with promises much easier and more reliable in your web development projects.